Hello there. Welcome to today's presentation on performance metrics. Today we're going to learn about some of the causes of UI bottlenecks and how we can diagnose and resolve them. My name is Nick Schultz. I'm a field application engineer at Crank Software. I've been with Crank Software for over 5 years. I'm currently in application engineering, but before that I spent my time working on the application development team. I've worked with customers across all different verticals, helping them design and develop embedded HMI solutions using Storyboard. And before joining Crank, I worked on the automotive HMI team at QNX, building reference HMI designs for the automotive market. So I've seen plenty of different applications and designs on embedded platforms, and I'm always super excited to see what's happening in our industry and where we're going now and what the next trends are. So a little bit, about the topic today and our agenda. So, we're going to cover a few different things. First is how Storyboard is different from perhaps some of the traditional frameworks you've used or how you've built UIs in the past. We'll talk a little bit about some common performance bottlenecks and considerations and how you can sort of detect and mitigate them. We're going to understand a little bit about latency and performance. Sometimes a sluggish UI isn't really a performance bottleneck, but, related to, data rates coming in or how quickly you can respond to something. And then finally, taking these concepts and kind of applying them to your system as a whole and understanding, how the UI fits into the bigger application picture. Using that knowledge, you can help define an architecture and design that, really sort of helps set you up for optimal performance. We'll then have a live demo and Q&A, and you can always follow up with us at our virtual booth. So first off, what makes Storyboard different? Storyboard starts off by providing a foundation for streamlined UI development for embedded products. The goal is that it really has to meet both the UI development and the design goals going in. And as you'll see, and if you've seen some of our other talks and presentations, you'll get that sort of design is an integral part of what makes Storyboard and the end products developed with them unique. We'll also give you the ability to strongly decouple the front-end UI from back-end core application logic. And, you end up creating a really well-defined data model and event structure that, gives you clean separation between UI and core application development. And, doing this, your UIs are more resilient to design changes, you can develop in parallel, and it's a much better workflow to follow. We're also not a code generation framework. So you're not sitting there hitting regenerate code or recompiling anything every time you make a change. You can design your application, run it, test it live on your desktop, and then deploy very quickly and easily to embedded systems. And finally, we do all the hardware optimization for you. So you don't really need to worry about any of that. You just need to focus on building an awesome user experience. So some common performance bottlenecks and, what do those look like? And, generally speaking, when you're building a UI and, if you've done this before or if you're coming into these things for the first time, screen redraw time and, the time it spends to update the display is sort of the first thing people run into. And, fundamentally, what this is you're converting your UI content, so your images, your text, your filled colors or canvases, things like that, and you're compositing them, mixing them, and converting them into pixels that are written to a display buffer and then transferred to the LCD. The more pixels that you need to update, so the larger the scale of the changes in reference to your resolution, the longer this will take. So there's sort of a little bit of a relationship there. And, generally speaking, you want to ensure that you change less pixels. And if you're doing this all manually, then, you have to do this diligently, and, you have to design your application to do that. And sometimes, this is easier said than done, especially if your framework doesn't really expose what triggers draws or how to control them. So, that's something that you'll see quite often. And to kind of compound this, if you've got expensive composition or blending, so if you think of a lot of stacked assets on top of each other, each unique thing needs to then be merged and blended together. And this can even be further compounded if you've got transparencies in alpha. So if you think of that, where multiple items on top of each other that have alpha blending or transparencies need to be blended with each other, so that the final pixel written to the display kind of has that resulting color that you might see of a few elements with transparency stacked on top of each other. And of course, as you might expect, whenever you're doing extra blending and extra logic, there's a cost associated with that as well. Another type of performance impact might be event overflow. And there's probably a lot of different names for this, but essentially you're sending data to the UI faster than you need, or even perhaps faster than you can service it. So a really good way to illustrate this is if you want to think about things in terms of frame rate, which is pretty common. 60 frames per second is a pretty common frame rate for what people consider to be smooth performance. And if you want to do this, you're going to have to sort of handle your event, update your rendering, your composition, and be done all within 16 milliseconds. So, if you think of it at that rate, if you start sending data updates every 5 milliseconds up to the UI, so perhaps speed updates from a CAN bus for automotive, or a temperature update from a sensor on a medical device. If you're sending it faster than you're drawing, then you have the potential of overflowing sort of your queue and what you're doing over time. So if everything you're doing, handling the event, processing the data, logic, updating the display takes you 16 milliseconds, but you've already queued up 2 or 3 other events behind it, you can see how you can start to get behind. Or if your system's architected in a way where you have to process all of the events before you go drawing, then you can introduce delays in processing and slow down how you'd be rendering. So these are all pretty common. Fortunately, there's a lot of optimizations built in with Storyboard to help mitigate these effects. So many of these things we do our best to handle for you. In the case that there isn't any, then again, the next stage and what we'll see in the demo is sort of how do you detect it and how do you diagnose it. So latency versus performance, similar but different. It's often something that people get confused and assume that you've just got a rendering bottleneck or a slowdown. And in many cases, this isn't the case, but in fact, sort of the inverse, where, if you're not getting the data fast enough, it can be just as bad. So if you think of smooth scrolling and draggable content, for instance, if you're scrolling a list and you can instantly tell as soon as the content isn't, synced up with your finger, or if it's lagging behind, and that's really, not a good experience. People don't like it. It doesn't feel snappy and reactive. So that's sort of the concept of latency. But often that's actually misunderstood, and people think it might be performance, where maybe you're not rendering fast enough, or it looks like you're dropping frames or something like that. You're not hitting that 60 frames a second threshold. And in the case of dragging and scrollable content, maybe it's simply you've got a low frequency of motion events coming in with data. And, kind of ironically, if you contrast it with the case of having too many events, from the previous slide, this can be, just as poor for performance. So, if you're only getting a drag event every perhaps 20, 40 milliseconds, then, things might look like you're stuttering and things are hopping and jumping, and it's not giving you that nice smooth transition. And, so it's possible that could be, something that has to do with the touch panel. Maybe it's just simply lacking the fidelity required to achieve what you're looking for, or maybe it's just lacking calibration. But again, the end result is what appears to be a poor performing user interface. Another aspect of latency, sort of coming down to, unblocking the UI and just making sure that the UI is ready to respond to events and data quickly as they come in. And a big part of this is how you architect your application. Your goal when building a responsive UI should always be to minimize time spent on being blocked or time-consuming logic. So, for example, if you need to query a large list of data, it's much more efficient to send, a sorted list that's already been formatted to the UI instead of sending, just kind of a raw, unordered blob of data. That way the UI doesn't have to sit there sorting it, replacing it, doing all the logic on it before it renders. And obviously this is a trivial example, but it can be applied to most scenarios. And really it comes down to making sure that tasks are being done where it's most efficient. The UI should be quite lean, generally speaking, in terms of when it receives an event with data and how it handles it and how it pushes it to the user interface. And if you're doing expensive calculations, perhaps processing data coming in from a bunch of different sensors, well, that's probably better to be done in a different thread, at a lower level, and then simply sending the results up to the user interface. This means that the UI can focus on drawing and performance, and your other aspects can focus on that core logic and work. And finally, looking at your system as a whole, this is starting to get into more general comments, and it's a bit of an extension of what we've sort of already covered. But the UI is part of your entire system, and at some point it's really worth examining what's happening as a whole and how your UI fits into the entire picture. And what I haven't really talked too much about, I've alluded to it, but Storyboard has tooling in place that provides metrics on things like CPU usage, memory consumption, event tracing, and rendering performance. And these are the things and sort of the data points that you're going to look at initially when you're trying to diagnose performance and a responsive UI. And those are kind of the metrics that will connect to that instant feeling that you get when you interact with something. And when you have real data, all of a sudden it means you can make informed decisions and take appropriate action when it comes to optimizing your application and removing performance bottlenecks. So if your system isn't performing the way you'd like it, you can very quickly examine one of our performance logs, and then you'll get a very clear understanding of what the UI is doing. And when you have data, bottlenecks become quite apparent, and it's pretty easy to track them down. And you can see if the slowdowns, maybe they're not actually happening in the UI. And if you notice rendering times and event flows look to be okay and good, but maybe they don't run frequently enough, well, or at least inconsistently, then maybe there's something else going on with a background task. Maybe something has a higher priority and it's preempting the UI from running. And with this information, you've got that real knowledge. You've got that information where you can go and then start to look and diagnose what's happening on your system, and it can point you in the right way. so that way, when you do go and, for example, run, the top command or system profiling tools on your embedded system, now you've got pieces and, you know where to look, and then all those other tools will help you fill in the gaps. So, all that being said, we're going to sort of force this back into the storyboard side, and we're going to jump into a live demo. I'm going to show you sort of how you can get a feel for what's happening on your system, and then some comments and techniques for how you can go around optimizing things.
Alrighty. So here is the Storyboard Designer, and what you're going to see here is one of our cluster applications, and it's a fairly simple UI. Not a lot going on, where you run and you have two events, a cluster update and a cluster system update, and those events pump data into the UI, and they'll do things like update the speed and the direction of the pointer that's rotating around a point here. And the first thing that we want to do is we want to run it on a system, and there's something going on here that means it's not quite performing how we'd like it to, and we'll take a performance log, and with that we'll dig into it, see what it looks like, and then make some changes. So I've already configured my system to do an SCP deploy onto my board, and this is a system without a GPU, so not very powerful, roughly 500 megahertz CPU, single core Linux system. So first thing that I'll do is I'll go and you can see here in my configuration, I've got the path, the IP address, all of that. We're going to execute a script after we go to launch the application, as well as open up a port for it to listen to, so we can connect to it and simulate some data. So we're doing the copy right now, and you can see here we've successfully copied it. We've got some diagnostic data here in the console, and that simply means, okay, we've launched and we're running. And what I'll do is I'll quickly open up a second webcam so you can see what I can see. So we've got our webcam pointed at the board here. Nothing super fancy, and apologize about the bad footage. But what I'll do, I'll pin this on top, is open up our connector tab, and because we've defined some events, we can actually inject some of these pieces into the UI. And you can see here with the RPM, dragging it around, it's not very smooth. It's lagging behind. I've stopped dragging, it's still moving. Same thing with the speed. And that's odd. That's certainly not the performance we want with a cluster. If this was a real system, that's not acceptable. So what we need to do is we need to do some logs, take some data, and then take a look at what's going on. So I'll move this off here. And we can start performance logging, where on the system here I'll define an output directory. So you can see /crank /perf-cluster.plog. That's a format we can use to open up a log file. And I'll say, okay, start logging. Drag this back up so you can see it. And, I'll go ahead and I'll adjust the speed. And again, pretty laggy. Do the RPM. And once that's done, we'll stop the log. And then we'll copy it over to the system and take a look at it to see what's going on. And it's worth noting that, because everything is event driven, that we get a very clear indication of what's happening. So I'll stop the logging there. I got a terminal open where I can just copy that over, and you can see we've got that perf-cluster.plog. And if we go and we drag it over, close that up, drag this in, we can actually take a look at what's going on. And I'll make this a little bit bigger so you guys can sort of see what I see here. And right off the hop, a few different tabs, general information, dynamic creation, deletion info, logging, and graphs. And we see some CPU metrics, average and maximum, and it doesn't actually look that high. This is, you know, sort of a case where, at first you may have thought, well, is this simply just throughput? Is it, it can't keep up with what we're doing? And, something's going on here, because if it was performance, you would expect this to be sort of full CPU where it can't keep up. And as you go down, you see these frame counts, average redraw time. The redraw actually doesn't look that bad. It's quite close to 16 milliseconds, which would be that 60 frames a second. But the average time spent for events, and you can see here this cluster update event, is around 125 milliseconds, and that's average, so it goes up higher, a little bit lower, which is really, really, really quite long. So what's going on here? If we look at the graphs again, we can see as time goes on, we've got some spikes. The CPU usage isn't actually too bad. We're at the top there, 29-30%, but the redraw is 62, and this may not be actually the time to draw, just total time 66. Not great. And from there, if you go over, and we can open up the log here, and we can see what's going on from when we start logging to when we stopped at the end. And we're going through, and you can see all of a sudden we've got these high duration times, 140, 129, 123 milliseconds on this cluster update event. If I expand that, dig through, we see, okay, it goes to our Lua script callback, the CB update event, and that's kind of where it stops. We're not calling off into another script or anything like that, and it's still taking 139 milliseconds. So that's kind of strange. Warrants a look. And if I go ahead and close that, close it down, and if we open up our script file, CB update handler, we're going through, we're pulling our data out, doing some math on it, setting our values, so again pointing them to variables, pushing them back in, and then we see all of a sudden we've got this OS execute. And this is here just for example purposes. No one would do this in real production code, I hope, but you can see here what's happening is we're calling sleep. And you could think of this, as the equivalent of getting preempted, and maybe something else is going on. In our example of a cluster with a data coming in, you'd be reading from a CAN bus and pushing that into the UI. So this tells us something else is taking over and stopping the UI from executing. And again, if we were to go ahead, delete that, save, and we could redeploy and retest. Redeploy our application here, and it's just sort of going to go up in the background, say okay, we see it running there. If I get the webcam up and running for you guys, here we go, always on top, and send some more events. You can see here now much more snappy. And that's exactly what we want. We don't want any of that lagging to be going on there. And I'm sure, that's where, most cases aren't that cut and dry. But, you can see right now when the system gets to run that, we're in a much better spot. And, we could run another log there. Again, starting our log. Jump some data in, stop our log, copy that over, if we drag that file in, all of a sudden, we're much better off. That average redraw being a lot lower. If we jump into the graph view, see we have some initial spikes where we're loading up some content, maybe getting a bunch of events coming in, but then it drops right down. And if we go back into the log, expand it, go through, you can see here we've got much better performance. And again, it's still not perfect. I'd say there's probably a few more optimizations that could be done. And you can see here a big part of this has to do with perhaps how much of the display we're updating. 20 milliseconds on the speedometer there. The rest of it's quite quick. But again, that's a pretty big win right off the hop, and that's where you could iterate on this, take more logs, check it out, and continue to make improvements. Alrighty. So that's our cluster sample. The next one I want to show you is an address book, and this is again one of our samples with a few changes that were made. And this is something that I want to do to illustrate some the common thing where it's sort of a combination of composition, so blending and rendering, as well as the amount of pixels that you're updating. So if we run our application on the desktop, you can see here we have an application going on. There's some scrolling happening there, and it looks all right. So things are good. We're happy with this. The behavior is good. We can deal with him. Perfect. And we're ready to test it and deploy it on hardware. So I'll go ahead and close this. If we do the same thing in our address book, I've got my deployment configured. So I'll run this, and it's going to SCP the content, deploy it over, and execute and run it. There we go. If I open up my camera again for you, you can see here, apologize on the quality again, but we have our address book. And we've got our people there, but the scrolling actually isn't that good. You can see it lags behind a little bit and isn't quite what we want. So curious again. So I'll go ahead. We'll take our nice performance log, and that's where, open that up. So instead of the perf-cluster, we'll just call it perf. Start logging. Oop, select the remote channel there. Perfect. All right, so we're doing our logs. Go ahead. I'll show you sort of what I've done there. And then we'll stop our logging. And copy that over. So you can see here now I've got my new perf.plog. Drag this in. We open this up. Let's take a peek at what's going on here. And, generally speaking, right off the bat, the CPU usage isn't good. We're seeing 90% usage, and that's quite high. Even though we're not using the most powerful board and processor, we can do better here. The average redraw time, longest ones for the contact screen, not great. And again, the stats over here on redraw back that up. So if we're already thinking about this from how does it compare to before, well, it seems like we're spending a lot more time redrawing as opposed to just time spent, whether it's preempted or something else. So if we take a look at our graph, which again is super useful here, we've got some metrics where the CPU usage, isn't super high. It's idle here. We're not interacting with it. And then all of a sudden everything jumps up and spikes. And you can see here, we've got a really high redraw, 108 milliseconds, even higher over here, 118. And that's just not really what we want. If we were to take a look at this, jump to that event and start sort of poking around here to see what's going on, you can see here 108. And there's a little bit of a couple different things going on here. If we condense some of this, so again, the contact screen is the one in question, so we'll take a look at that shortly. But as we expand that, there's a few different areas that are sort of showing up and spending time, all of which are higher than that 16 milliseconds that we're going for. But the first one is this background image. That's the tree background. It's a 800 by 480 or even more solid image. Not a lot can be done about that, where it has to be rendered, but that's still pretty high for something that's been cached. So there must be something else going on there. We've got our table controls, and again we see 11 milliseconds here for the contact list, the highlighted one. Stanith, what's going on there? We've got 11 milliseconds. And finally, that contact select layer, that contact background, 18 milliseconds. Again, that's not a full screen one, so again, something must be going on there. So we're going to jump back into our application, take a peek, and we're on our contact screen here, and start going through. So if we reference our performance log, and I'll just sort of collapse some of this for you as we go. We've got three main areas to look at: the tree background layer, the table layer, the contact select layer. All of them are taking a lot of time. So the tree background layer, as we discussed earlier, that's a single control. Nothing super special about it. It's actually a little bit bigger than the screen, so not too bad. You could trim it down. You might save a little bit, but again, that's pretty fixed. So for now, we're going to leave that as is. The next was the contact select layer, and the contact select layer, if we go through, oops, it's that background image. So contact background, open that up, contact background. All the other elements don't seem to be really going on. And the funny thing, if we're going through this, we notice the alpha is actually set. And visually, you can't really see what's going on too much. You can sort of see behind there, and it's a little bit more apparent on the first screen, where the cells are going through. So all of a sudden there's alpha, which means there's a blending operation happening there. And maybe that's by design, but at 250, maybe that was just something where it accidentally got bumped, or you can see it's up and down. So if we make that to 255, lock that in, that'll stop any blending happening there. And because the cells are actually moving behind it, you've got this entire area here where there's blending operations occurring, which is a lot of logic. If you've got a GPU at your disposal, then that's probably not a big deal for it. But in this case, you can see how each thing might be starting to add up. And if we look at the table elements, you can see this table is actually all the way out here. And since we've locked that in, we probably want to resize this, something like that, maybe even a little bit smaller, like that. So now all of a sudden, if we have motion, we're not actually redrawing that entire area and blending it. And this all of a sudden, if we go back to my original thing where we say, the more pixels you update, the longer it takes, we've now cut down that area. And the engine is going to, be as smart as it can about this, where, before there was overlapping, it was blending there, but now the only area on the display that's going to be updated is here. And we still remember seeing, the contact list elements had something going on with them too. So if we select that, we can see they're larger than they have to be. So again, if we lock them down to be 300 there, reduce that, and we see we also have more alpha. And maybe, if we quickly run this to see what it looks like, maybe that's by design. But, probably, again, I suspect it's, something that if we update it, doesn't really make a big difference. So if I go ahead and put that back up to 255, start looking at the other elements here, there's a favicon that looks to be okay. That's hidden, but again, that's 0, so we're not drawing it. And then this background image, go ahead, set that up there. And if we do that, save this, and if we run it again, again, the desktop's a very powerful machine, so everything seemed pretty good. But, if we go ahead and we run this on our embedded board again, take some metrics, I bet you we'll see a noticeable difference. So I'll go ahead, I'll deploy that, and start up the camera again for you. And as we wait for, there we go, pin that up. All right, so if we wait for this application, inject some data to it. Oh, sorry, not injecting data. We're going to start the logging, and we can see here, everything is much more locked and smooth. So that's, kind of exactly what we want. Nice, nice scrollable elements there, nice and smooth. If we start our logging up here, nice. Stop the log. Run that. We can now get some better data. Copy that over. And if we pull that in, clear the old one, close that down, drag that in. You can see now our times have dropped pretty significantly. They're in the mid 40s beforehand. Now we're down closer to 25. Again, if we look at our graphs, it's a little bit better. Again, remembering things are scaled here. So if we jump into the logs, expand that out, our times are looking smoother. So, we're not hitting that 60, but again, there's some optimizations that could be made again, and all of a sudden we don't have those high costs of blending. The tree background layer, we don't have that incurring as much of a hit. Now it's 7 milliseconds instead of, I think it was around 18 before, something like that. And we're going through. Really, the only area that's having a major bit of logic on it is the list, and that's what we're scrolling. So again, this is more of a each element has a bit of a cost associated with it, and I'm sure there could be some tweaks there as well to improve performance. But again, just taking a quick look, this is how you can get some results from your testing on hardware, make some acquire some data, make some adjustments, and start iterating the flow. So I'm going to jump back into the slides now. So first off, if you're curious of how to go about setting all this up, how you can do the SCP deploy and configure the engine for your hardware, check out our knowledge base, support.cranksoftware.com. Lots of information there, video tutorials, links to the documentation, downloadable demo images, all of that. So really a great resource, and that'll get you started. And then, some takeaways from this, apart from visiting the Help Center, we want you to download our software, free 30-day trial on the website, cranksoftware.com, play around with it, and then connect with us, talk to us, see what you're doing. We'd love to hear about what your projects are and how we can help get you started and bootstrapped, and swing by the virtual booth to have a conversation as well. So, really looking forward to, talking to you about everything that you're doing. And if you have some common evaluation boards, then we've got demo images that you can take a look at, download an SD card, flash it on, and get straight to prototyping. So, our goal is really to help you accelerate your development and prototyping and get to market ultimately faster with a great user experience. So, thank you for your time. I really enjoyed this presentation, and I hope you found it entertaining and you learned something as well. So looking forward to learning about all the new technology and projects out there, and I hope to speak to you guys at the virtual booth. Thank you very much. Bye.